key to this question is understanding the connection between velocity and displacement. Now, prior to A-level, you have learnt that velocity is distance over time, and you also know that acceleration is velocity over time. Now actually, velocity is the change of displacement over the change of time, and acceleration is the change of velocity over the change of time. Now what you've learnt in A-level is that we can turn this into dx by dt, and for acceleration we can turn it into dv by dt, and that comes from considering these things as dynamic situations where things are changing, and we therefore have to look at calculus, which is the mathematics of change. You've also learnt in A-level that differentiation and integration are inverse processes. So that means that if v equals dx by dt, then we can imagine, this isn't a correct mathematical statement, but we can sort of imagine timesing both sides by dt. And for this one we can imagine the same. And we put those in inverted commas because they are not strictly proper mathematical statements, but it does sort of lead us to see that if we integrate both sides, and we know that the integral of just dx is the same as the integral of 1 dx, which is just x. So the integral of v with respect to time is x, and the integral of a with respect to time is v. So once we remember that, or know that, we can fairly easily tackle this question. We can see that we have the formula for v is given, and we want to know what the displacement is, so that means we can integrate. So we're going to integrate v, and that will give us our displacement. And we don't know where we're going to integrate because we're not given a beginning and an end, but we are given one particular value. So we know that at time t equals 1, the displacement's minus 4 meters. So what we're going to do is to put in the formula we've been given, 6t squared minus 8t minus 5 dt, and t squared becomes t cubed over 3, and we've still got our 6 there. T becomes t squared over 2, and there's our 8, and the 5 just becomes t. And also, because we don't have the boundaries for this integral, we have to put plus c. Now the detail for how that integration has worked, you'll find in one of the other exam revision videos. And now we can do a bit of cancelling. 6 and 3 cancels to leave 2. 8 divided by 2 is 4. So we end up with 2t cubed minus 4t squared minus 5t plus c. So at this point we're nearly there. They want a general expression for the displacement, but this c is a problem. We don't know what that is, and that's where this known condition comes in. So it says that the particle displacement is minus 4, so x is minus 4 when t is equal to 1. So we can substitute those into the work we've done so far. So we have minus 1 is 2 times 1 cubed, take away 4 times 1 squared, take away 5 times 1 plus c, and that means that c equals the minus 4 take away 2 from the 2 times 1 cubed plus the 4 plus the 5, which gives us 3. And so we have our final answer, which is that x is equal to 2t cubed minus 4t squared minus 5t plus 3. Now, if we had time at the end of the exam to do a bit of checking, there's a couple of quick checks we can do here. First of all, we can check that our statement of the answer works in terms of v being equal to dx by dt. So we could differentiate it. So that would give us v is dx by dt, which would be 3 times 2t squared, take away 4 times 2t, take away 5, and then the plus 3 just becomes 0 when differentiated. And that gives us 6t squared minus 8t minus 5, which is what we would want. So it's passed that check. The second check is a bit boring in this case, but we could put our t equals 1 from the original question and see if that gives us the minus 4 that it should. So that would be 2 times 1 cubed, take away 4 times 1 squared, take away 5 times 1 plus 3 gives us 2 take away 4 take away 5 plus 3, which is indeed minus 4. So it's passed that test. Now, before you go, I just want to mention another way that might help you to remember this equation here, which was the key to this question. And that is that you learned quite a long time ago now that if you do a velocity time graph, and in GCSE you would often have something like this, say, and you might be given various values, so you might know what this one is, t1, t2, t3, and you might know what that velocity was, and they would ask how far has it travelled. And the way you would work it out is you would work out the area under the curve. So that would be a little triangle plus that rectangle plus the other triangle. So given that you now know that area under the curve is the integral, then this actually is the integral of the function, which is the velocity function, with respect to time, which is on the x-axis. So if you're struggling to remember how to do a question like this, then thinking about this simpler way that you once used to do it, and probably still do from time to time, could be a way of jogging your memory.